Okay, so these are kind of tricky problems, right? I'm going to use a couple things here, right? An electric field exerts a southerly force on that, right? So from the force and the charge, we can find the electric field, right? So the electric field is force divided by charge. So let's do that. So it's 3.30 newtons south over 450. This is positive 450 times 10 to the minus 6th coulombs is equal to, that is 7333.33. All right, and that's simple enough, right? So we got an electric field. It is in the direction of the charge. Had that been a negative charge, by the way, we would have gotten negative to the south, which of course would be north. All right, that's the first step, right? So now my second step is that I'm going to use E is equal to opposite of VE over R. Okay, we really are going to use this minus sign here, so let me just show you that. So go 7333.33 newtons per coulomb south equals the opposite of the change in potential over. Okay, now notice that I say I displace myself to the north. This is a troublesome thing, right? So what I'm going to do, 7.3 centimeters to the north is the same as negative 7.3 meters south. Right, so I'm going to do that as negative 7.3 meters south. We're just going negative south. It's north, right? Okay, now take a look at this, right? We got a negative there and a negative there. Those things go away, right? And so now all we do is we multiply, right? So we go 7.3 times 7333.333, and you end up with the change in is equal to 53,533, and then a lot of threes. There's so many threes here. Three. This is going to be joules per coulomb, right? And the reason it's joules is that newtons multiply by the meters and make Newton meters, which is a joule, right? Yay! Okay, it is an increase because that number comes out positive. Now, let's suppose that that's not a satisfying answer. You're like, geez, I don't really want to rely on the math. Now, stay tuned here because I'll explain, why this has to be a change in potential, right? Okay, so I guess I have to erase this stuff, right? So now we've got this region in space, right? And this is south. They'll go north and south and east and west. Right, and then we have a southerly. We decided that the electric field was 733.33 newtons per coulomb south, right? Okay, so here is positive, right? Here is negative, and the electric field is south. It's this way. Because remember, what would positive charge do? Positive charge in this case would go south. A positive charge right here would experience this field as a downward force, right? A southerly force, and I'm making south down, okay? So what is the change of potential if you displace yourself 7.3 to the north? Well, if I go that way, aren't I going toward the positive? So therefore, isn't it an increase in potential? If you go toward positive, it's an increase. If you go toward negative, it's a decrease, okay? So as a student, I would always draw a picture of this. Right, I'd always say, okay, look, positive is there, negative is there. That's how there's a southerly force. That's how there's a southerly electric field, right? So then if I go north, if I'm going north, I'm increasing my potential, okay? Anyway, yeah, there you go.